In this video, we're going to talk about KL-divergence. We will first see the definition and work through an example, and then we will see how it's related to cross-entropy, which is a commonly asked question. Finally, as a bonus, we will discuss several interview questions, some of which you'll already be able to answer following this video. So the KL-divergence formula simply measures how two distributions differ from each other, and the best way to understand this is to work through the formula with an example. So say we're training a neural network to classify dogs and cats. In reality, which is modeled by some perfect parameters theta, this image will get a label of 1, 0, 1 for dog and 0 for cat. Now let's assume for a minute that our neural network, modeled using parameters omega, which are our network's weights, failed miserably and chose to label this dog as a cat, producing 0.1 that this is a dog and 0.9 that it's a cat. So let's plug these into our formula and see what happens. In the first term, we have the probabilities for outcome dog. So blue is from theta and red from omega, and so we get 1 log 1 over 0.1. And similarly, we get the second term, which, as you can see, is essentially 0 times log 0. Now, log 0 is undefined, but a simple solution commonly used is to set 0 times log anything as 0. So the second term is simply 0. So this gives us 3.3. Now let's see what happens if we fix our neural network, and now it does a great job. And instead of 0.1 for dog, we have 0.9. Plugging this in, we get 0.15 this time, which is much lower than the previous 3.3, and it's actually very close to 0. And in fact, if we had a perfect model, KL-divergence would give us precisely 0. Now, KL-divergence is always non-negative, and I've left a link in the description in case you want to see the proof as to why this is true. But what's important to realize is that 0 is the minimum, and that we get 0 when we have a perfect model, as we just saw, and higher values when we don't, as in our first example. So why is KL-divergence useful? Well, now we can use KL-divergence as a loss function, or something to optimize, because we can strive to get to the minimum value of 0, which is the perfect model. In fact, the closely related measure cross-entropy is used to accomplish just that. So how are the two related? Well, what we can do is we can take the log and split it into a subtraction and get these two terms. Now we can see that the negative part is the cross-entropy. It's simply the definition of the cross-entropy between the two distributions p theta and p omega. And then the first part is the negative of the entropy of the real distribution with parameters theta. Notice this is a constant because it's determined by the real-world distribution parameters theta, which in machine learning would be determined by our labels, for example. So these don't change and don't depend on our model parameters or network weight omega at all. So if we're interested in learning the optimal omega, which only appears in the second term, this constant can be ignored. And so what we're left with is just the cross-entropy. So we can see that if we want to minimize the KL-divergence between the real-world distribution with parameters theta and our estimated distribution with parameters omega, then this would be equivalent to simply minimizing the cross-entropy between the two. Now, if the optimal omega would be the same, why do we always use cross-entropy when training neural nets? Well, one reason could be to avoid the division operation inside the log, which is computationally expensive, or just overall avoiding computing redundant terms like that constant. So because the minimization will produce the same omega, we can choose to use cross-entropy. But notice that if we were interested in the value of KL-divergence itself, this would not be the same as cross-entropy. But we're only interested in the learned parameters. So now that you've watched this video, you should be able to answer these first two interview questions. 1, what can KL-divergence be used for? And I urge you to think of other examples besides the one we've discussed. And 2, how is it related to cross-entropy? And if you're looking for more practice that involves additional topics in machine learning, 2 other interview questions are, is KL-divergence a distance measure? And how is it related to log likelihood? So you're welcome to discuss these in the comment section below, and if you like this video and would like to see more like this, then make sure to subscribe.